This is the lecture that goes along with Chapter 9 of your textbook entitled Advanced Modularization Techniques. So we've talked about modularization in the past, so we're going to go back and visit some topics that they consider advanced. So we're going to talk about the parts of a method. We're going to talk about methods that do not have parameters, methods that do have parameters, and the fact that methods need to return a value. So we'll talk about what kinds of things can be returned. Arrays are passed a little differently to methods than normal variables, so we'll talk about that. We'll talk about overloading methods. We'll talk about using predefined methods that have been predefined some way. And then we'll talk about implementation hiding, cohesion, and coupling. Most of those things we talked about to this point deal or are the basis for object-oriented programming. And then this last topic is kind of standalone, talk about what recursion is. So a method is just basically like a function. In a lot of programming languages, for example, I teach Perl programming. So during Perl 1, when we're talking about kind of normal procedural type programming, we call functions functions. And then when we get into advanced Perl, it's like, oh, when we're talking about object-oriented programming, we're used to say function, just use the word method now, and it's the same thing. So we kind of already know what methods are. They're chunks of code that we can call from within our program or possibly another program, and there is no limits on how many methods we can have, and there is no limit on how many times we can call those. Now, there are three things when we talk about a method that are required. We have something called the method header. It's also called a declaration or definition. Now, a lot of times when we write programs, I tell you need to have a proper header at the top talking about your name, the assignment, the due date, what class it is, and a description of your program. This header is something very different. It's basically defining the name of the method as well as the arguments that you need to pass into it. You need to have a body, which is programming code that carries out whatever algorithm or function the program is supposed to do. And then when we want to return control back to the calling program, we need a return statement to signal exit this method and return to whatever called me, possibly returning a value. As far as variables and constants, we've talked about scope before. A variable that is local to a method is declared in the method and is only known while we're in that method. Once we leave the method, there is no way to access that. Global, as we talked about before, is known everywhere in the program and in the program methods that it might be calling. So here they're showing you an example that calculates a user's weight on the moon. And what happens is this program works in both English and in Spanish. So if we look at the display instructions, it first asks, do you want English or do you want Spanish? And in the example on the left, the person typed in a 1 saying they wanted to have Spanish. So what happens is they would then, based on that language code, either output the Spanish prompt or the English prompt. Now, in this case, the parameter has no methods. Display instructions actually ask what they wanted to do. Well, there might be a better way to do that. We might get their language somewhere else and then pass that in as an argument to that method and possibly other methods. So maybe not the best way to solve that problem, but it is an example of a method that has no parameters. Now then, if you have no parameters, that can be an issue, because what if you need to pass data into your method for some calculation to perform? That's the problem with no parameters. And then also a little bit out of place talking about returning data out of the method. You can have methods that have no parameters that do return data. They're kind of implying otherwise here. Now then, when you call a method, you need to know the name of the method you're calling. You need to know the arguments or the information that you're going to pass into the method. And then if this is going to return some value to us, you need to know what type of data type that return value is going to have. So argument and parameter, these are going to seem very similar. When you call your method and you say, I want to pass A, B, C into A, B, C, A, B, and C are the actual arguments that you're passing into your method. Now, when your method's declared, it's going to say, I get 3 values. I'm going to call them X, Y, and Z. So what happens is those arguments and parameters need to match in type. And when you go into the method, whatever is A is going to get copied into X, whatever is B is going to get copied into Y, and whatever is in C is going to be passed into Z. So the parameter is how we refer to the arguments while we're in the method, but the actual arguments are what is passed into the method from the calling program. The parameter list or the argument list is just a list that is comma separated that includes the type as well as the name. In the example I gave you, I only used the name, but the types do have to be declared and in the parameter list, and whatever you pass in from the argument list has to match. The method's name, along with its parameter list, is referred to as a signature for that method. Now then, what they're going to do is they want to rewrite the program, or they're thinking about how to make the program better. We can rewrite the program without any methods, or we can do display instructions with no arguments, and then have something called language code, which is a global variable that everything can look at, presumably set in the main program, and then used in our display instructions. We can retain our display instructions, but add a section to the main program that also asks for the preferred language, or we can store their preferred language in a variable in the main program and then pass that into the method, which is going to be the best way to do that for a lot of reasons. In the example that I gave you and what they just talked about in the book, that copying from arguments into the corresponding parameters, when that copy happens, that's referred to as passed by value. So we're actually copying the values from the arguments into the parameters. Each time that we call that method, that copy occurs for things in the argument list into the corresponding variables listed in the parameter list. Now then, the example we just talked about, you might have one parameter, which is the language code. You may need no parameters, you may need 1 parameters, you may need 10, you may need 100. It just depends upon the problem that you are trying to solve. So when we declare these, we have comma separations, we have the type, and then we have the name that we're going to use. The arguments that are sent in are sometimes called the actual parameters. In my opinion, it's better to call them arguments and parameters, but the values or variables that accept these actual parameters in the method are then called formal parameters. So it's just a slightly different way to talk about the information that you are passing in. So here they're showing us that we have something called compute tax. It takes an amount and a tax rate. So we have 2 numeric values that we're going to pass in. So if you look up at the top of this flowchart between the start and stop, we get a balance and a rate, and then we call compute tax. Into compute tax, we pass in balance and rate. That gets matched up with amount and rate. So whatever's in balance will be copied into a variable called amount that is local to the compute tax method. And whatever is in rate in the main program will be copied into another variable which happens to be called rate but is local to the compute tax method. When you have two names like that, when we refer to rate, we're going to look for the rate that is the closest in scope. So if there's a local variable called rate, we'll use it. If there happened not to be, then we would go and look for global variables named rate. So down at the bottom we have pseudocode representation of the same thing as well. That is declaring compute tax and calling or accessing or invoking compute tax in a main program. A variable declared within a method ceases to exist when the method exits. So I think I've pretty much said that or alluded to that. Another way to say that is it goes out of scope. So if we had a tax rate in our compute tax method, as soon as we return back to the main program, that value and that variable is going to cease to exist. If we want to keep that value, then there's several different ways to do it, but what they're saying is we need to pass whatever value we need back via a return statement to the main program. And when we do that, the return type we declare of the method, that is the type of data it's going to return, needs to match up with the program's variable type as well. So the return type specifies the data type, and it is listed in front of the method name. One thing that we haven't talked about, I don't think, is void. Void means nothing. You can have a return type of void, which basically means I return nothing. So I'm going to perform some task, but I don't need to pass any data back to the method or the main program that called me. So here's an example. We're going to call a function called getHoursWorked. Not exactly sure what that does yet, but it's going to return a numeric value, which presumably is the number of hours worked by somebody. And it says that you usually want to use the return value in the calling method, but you don't have to. So for an example here, they're going to say hours worked is, and that's going to be followed by the numeric value that was returned by get hours worked. But they're saying what you would do a lot of times is store that in a variable and then print the value of the variable. You would definitely need to do that if that return value needed to be used again in your program. So here is an example. So get hours worked takes no arguments. It asks the person how many hours did they work, and they return that back to the main program. So this is a relatively trivial example, but it shows that we have no arguments, no parameters, but we do return a numeric value. We know it's numeric because in the method header, we declared the data type as being num. I don't know if I fully agree with this, but basically what they're saying is your module should run top to bottom, doing any loops, making any decisions, and then you just have a simple return statement at the very end. And they're saying not doing that violates structured logic. The reason they say that is that's kind of a hidden go-to. And, go-tos are very, very bad, should never, ever be used. But a lot of times what happens is if you find out you have an error condition at the top of your method, you might as well go ahead and return something like -1's used a lot of times to say, hey, something didn't go right. If that's not the case, then you would continue on with your method returning a value later. So even though technically it is bad programming style, a lot of times, I would say very frequently, that is used to kind of early abort a function or a method. So they're showing you this unstructured approach where you're returning as soon as you know first is the largest value, you're going to return first. If that's not the case, if the second value is greater, you return it. This actually makes for a little cleaner code from a reading standpoint, but again, keep in mind that it technically is unstructured. So what we would do is we would want to go through and have a variable, for example, called largest, and set that value, and then say return the largest value. That is the improved, correctly structured program. Now then, to use a method, there are things you need to know. You need to know what it does in general. You don't necessarily need to know how things are stored internally, what algorithm it uses. You just need to know the name, know what it does, know if there's any required parameters that you need to pass to it, and then you need to know the return type of the method so that you can store that in a variable or an array of the appropriate type. To do this, one tool we have is an IPO chart. A lot of times, just like you have a header for your main program, you would have a header for each module in your program, and it would contain the same information. Instead of having 3 columns, if you were typing this in a set of comments, you'd probably have 3 sections. But the I is for input, so you tell what values you're going to input. You would also put the type. For example, they need to tell you these are numbers. Then as far as processing, this is a brief description of what your program does. A lot of times, this processing section might be, it takes the 3 values you pass in and returns the largest value, or in this case, smallest value. And then the return or the output is the smallest value. So they actually went a little bit more into detail, almost explaining, process by process, decision by decision. That might be a bit much for an IPO chart. So again, you're providing an overview of the input, the processing, and the result of calling your module. This may just be for you, so that when you come back and use it, or look at it a year later, you don't forget. Or maybe this is a module you're going to share with other people. And if that's the case, then this is the documentation that they would use to figure out how they were supposed to call your module. Now then, before we talked about simple variables, that is, variables that are not arrays. They were passed by a value. Well, there are times you want to pass an array into a method, and we want to just give the array name and input or pass the entire array. What happens is arrays are passed by reference. And basically what reference is a lot of times called a pointer, but in this book they've been referring to addresses in memory. But a reference or a pointer is an address, and in particular, when we pass something by reference, it's the pointer to the very first part of, in this case, an array. And then based on the array type and other things, when you say I want the second element, it can perform math on those addresses and pull those out of memory for you. So here we have an array, and they're just saying they want to quadruple the values, and then they just pass the array in. And then you go through and process the array. It says quadruple the values, but output some number of x. So I don't see that it's actually quadrupling it, but it is passing 4 values in. So basically what we're doing here is we're going through looking at the length, and we're outputting the values, and then we're multiplying them by 4 and then outputting them again. So that was actually not the code. It was just calling the quadruple the values. Here we have pseudocode, and then we have an execution of the program where we get the values. It echoes back what the values are, and it tells us that we're in the array. So that's kind of proof or a test that yes, it actually did pass all those values into the method and we can use them. Then it multiplies all of them by 4, tells us what the values are, and then at the end of the program, when we go back, we see that we still have the same values. Because when things are passed by when things are passed by reference, we're actually changing them in memory. So before, if we had something, for example, rate that we changed, and when we left the method, that fact just disappeared. That variable no longer existed. Here there only is one array in the main program, and our module, because it was passed by reference, is actually changing the memory locations, in effect changing the values in the calling program's array. Now then, overloading is having different meanings for a single identifier. They say diverse, maybe it's diverse, maybe it's not. They give example here. People say that English is a very hard language to learn because we use words that sound the same, or in some cases spelled exactly the same, pronounced exactly the same, to mean different things. But somebody that speaks English would understand break a window, break bread, break the bake, or take a break. They would understand that even though we're using the word break, it means different things depending upon the context. When we do that, we can overload methods by using method names with the same name, but the way they're differentiated is they have to have a different parameter list. So we can do that. A language that supports this is said to support polymorphism. That is, we can act appropriately based upon the context we were called in. So if we were called with 4 arguments, of a certain type, then it's going to know which function to use based upon the argument list and the parameter list in the method's signature. So here we have something called print bill. If we print bill with 1 argument, which is a balance, it's just going to say, hey, you owe us this much money. If it's maybe a volume customer or a really good customer, you're going to pass the second argument, which has a discount rate, and you're going to apply that discount rate to lower their balance, and then tell them here is the balance that you need to pay. So based upon whether we pass 1 or 2 arguments into print bill, we'll determine which of the methods we call. So they both have the same name, but they're 2 different methods. Here, they wanted to thank the person for the order. You could give a balance and a message, or you could give a balance, a discount rate, and a message. So that's just another example of how you might slightly change the print bill. You don't have to overload methods, but a lot of times it makes sense to do. For example, addition means different things to numbers versus, encrypting characters, for example. Now then, if it is a related task like billing, it may make it easier for somebody using your method or for you yourself to remember the name. So if you have 5 objects that you're working on, you don't have to remember 5 different method names. One thing that you want to avoid, because it's going to cause you problems, is what's referred to as ambiguous methods. That is, the compiler cannot figure out which method to call because there are 2 or more methods that have the same signature. In that case, you will receive an error message. So here they're just showing you an example. Print bill, balance, discount in dollars, and discount rate. They both have two arguments, so you can't figure out, at least in most languages, which one to call. So you need to make sure you have different method lists, and if you do have something that is identical, in this example you have two ambiguous methods because they're both called a method, and they have an identical argument list. That is, they have a single number. So those are not going to be overloaded. They're just going to simply be ambiguous, and you want to avoid that. Predefined methods. A predefined method is a method that has already been written. Now, kind of the confusing example is maybe you wrote this method yourself to use in many different programs. So you have predefined it at some point in the past and are using it. Another example of predefined methods are methods that are built into the programming language you're using. Maybe you're part of a team and somebody else had the responsibility of writing the methods, but you're going to use them in your code. And you might even do that on a corporate level where you have a library or collection of methods that you can use. The advantage of this is they save time and effort. You don't have to reinvent the wheel. If the method is already there, you use it. One of the big advantages that they don't mention is, hopefully this has been debugged and used many, many, many times and is not going to have bugs, where if you rewrite this from scratch, you may introduce problems or maybe not program all the defined behaviors that the method's supposed to have. You can use output methods to make sure your output is consistent, potentially of a specific format. And if you do lots of different calculations, but you use those calculations over and over and over again, then you can define those as a method and call those as well. So those are some of the advantages. To use a predefined method, you first need to know that it exists. You need to know what the name is. You need to kind of know what the method does to make sure you're choosing the right method. You need to know what parameters you need to pass in, and you need to know the return type. So these are all the things that you needed to do when you were writing a module yourself. Now then, I alluded to this before. This module can basically be a black box. That is, you have no idea how they represented the data. If it returns a sorted list, you have no idea if they used a bubble sort. You potentially don't know anything about the code. You just know how to call the method and get results back. When you're designing things, there are several things that they're going to talk about here. Implementation hiding. That's what I just talked about. We're in a black box. You don't need to know the internal algorithms or mechanisms. If somebody rewrites that method, they could totally change the internals. But if you had a copy of that new module, it would still perform the same way. Maybe it's a little quicker, maybe it's not, but it could be different code. So that's what the implementation hiding is. The interface to the method is the only part of the method which the client uses. That is its signature. And again, they say it's a black box. Cohesion is basically how the internal statements serve to accomplish the method's purpose. So basically what this comes down to is how much do we put in a method? Do we put lots of statements and do several things, or do we break it down into smaller parts? If you have high cohesive methods, that means you have a library and all these relate very closely. So if you had 5 subroutines and they somehow reacted or interacted and performed bubble sort, you might say, hey, this is a bubble sort library. It is has high cohesion because all the items in there relate to each other. Now down at the bottom, they say they're usually more reliable than ones that have low cohesion. There's a couple of reasons for that. One is because there are typically less methods. So less methods is usually less places to cause a problem. And they're typically written by one person that kind of knows what they're thinking and, define the methods and the data types and the functionality. So they're more cohesive from an understanding standpoint. Coupling deals with how much methods depend upon each other. A loosely coupled program, the methods do not depend upon others, and data is passed to one method, then a different method. Instead of having a method call a method, call a method. Tight coupling means that we do have this chain of excessive dependency upon each other, and a tightly coupled program, maybe contrary to what you would think from the name, is probably going to make your modules or your program more prone to error. Okay, and the kind of topic that they threw in here, because it does deal with methods, is recursion. Some programming languages do not allow recursion, but most, and especially most modern programs do. So basically, recursion is defining a program in terms of itself, which means if you call method X within method X, it's going to call method X, which may in turn call method X again. So basically, it is calling itself over and over again. Every time you call a method, you have some local variables that need to be stored on something called a stack. You push things onto a stack, and when you need them back, you pull them off. So a stack grows when you push things onto it and shrinks when you're pulling things off of it. So when a method ends, it's going to pull all of its data from the previous call off the stack and use it. So again, that would be things like local variables. So here is an infinite loop that is created by recursion. So basically in the main program we call infinity, and infinity prints out the string help exclamation point and calls infinity again. So we're just going to call infinity over and over and over again. This will pretty much be an infinite loop until we run out of stack space, which is limited by the amount of memory on the machine. So at some point we'll get an error message that says the heap is full or the stack is full or memory is exhausted, something like that. So as they're saying in the first point, is exactly what I said. You may run out of memory. So what we need to do is we need to have a way for the recursion to stop. So in this case, we input a series of numbers, and what we do is, when the number is 1, we call cumulative sum, and cumulative sum calls itself for 1 less. So basically, what it's doing is, for example, 2 plus 1 is 3. For 3, we would do 3 plus 2 plus 1. For 4, we would do 4 plus 3 plus 2 plus 1. So basically what it's doing is saying the cumulative sum of some value x is x plus the cumulative sum for x minus 1, which you see in the highlighted box in the pseudocode. So that's what recursion is, and here's an example of how when you get down to the cumulative sum of 1, the answer is 1, and you just simply return 1. So that's basically, this is how you would go through and do that if you were not using something recursive. So you can solve problems without recursion, just sometimes recursion makes things easier to deal with. So that finishes up the lecture on Chapter 9 of your textbook.